Next, our focus will be shifting to empowering R&D through HPC and AI. We welcome Dr. Weicheng Huang from HPC Taiwan to give us some thoughts. Thank you.
Hi, everyone. Thanks for having me again. And I'm going to talk about what NCHs have evolved over the year, okay? And where's the, this? Oh, where's the slides? Should I put on my slides or?
I think they are not showing this. Yeah, the slides are not showing. Yeah. I think they should show from there. Yeah.
Oh, here we go.
Okay, cool.
Right, thank you. So I'm going to talk about what's happening in HPC and also the AI of the center. Okay, this is the two slides I was asked to put on because the government thinks, we're under the NSTC and we are under the NIR. But here I would like to urge you that in terms of personality, number of employees, we'd like to take about 17% of NIR, but about the budget is 27%. All this because of the AI, all right? So skip this. So we are the typical supercomputing center. We do the numerical simulation. We also trying to build a trust data platform and, of course, AI, and we are currently moving on to the digital twins. So I'm kind of addressed a little bit like in this area, and of course, the quantum computing, but we are not there yet. So everything you saw on this, if we come with a light color, means is something we are working on, it's not there yet, okay? So we kind of revisit the mission of the center over the years. So here are the four area we are focused on. First, we are kind of providing data platform, and hopefully we can provide a secure data platform for all the application to use. Of course, we need to provide infrastructure like computing, storage, even the network itself. And we are focusing on the AI for now. And of course, HPC is not abandoned, okay? And also we are working on the possibility of have quantum computing to come up sometime this year. So this is the whole milestone of the center. And we started from, we are founded in 1991, and it go all the way to last year. We have the most updated machine called Nano 4, was established in the end of last year. And hopefully it will become production next month, right? And you might be able, or here I would like to point out is, in addition to AI GPU machine, we actually also provide a CPU. And the reason is, well, everybody the government say you should move on to AI, you move on to GPU, but our academia say I need a CPU machine to run our typical simulation. So if you take a look in terms of computing power, say it's for 2017, which is retired, the Taiwan 1 is 1.7, followed by 9 petaflop, but it dropped back to 2.7, go up to 3.8, drop back to 3.5, go up to 13, and up to 81, right? So all this smaller number machine is basically CPU machine. So Taiwan 1 is CPU, and go to 3 CPU, 4 run is CPU. So you might see the TikTok situation here, right? Because we want to build a GPU machine, but later on people complain, I need a CPU machine. So we turn back and build a CPU machine, right? In addition to the machine, because the power consumption, also the weight of the GPU machine, we kind of build a new data center. So we have one new data center which is in production last December, and we are going to build another one later. You will see that, right? So these are the workhorse currently in the center. On the left side, they are GPU-based. The Taiwan 2, which is going to retire next month. And also we have Nano 5 and Nano 4. You might be wondering why 4 came after 5, right? First I saw this naming strategy. I also, well, anybody did a wrong job, But it ended up like Nano 5 is based on 5 nanometer chips-based system. And Nano 4 is based on 4 nanometer. Oh, I still prefer that flip it around. And on the right-hand side, we have CPU machine, right? pure CPU. And so are we going to build we are going to build another machine this year. Its procurement might have a result the 1st of July. And we are not expecting to have something because of the price of memory, all those things. So the original target is like have 114 petaflop at least, but we are kind of dropped this number already. So we don't know what we are going to get, but it's GPU, all right? So we come back to see the utilization of the system. This is typical slides. I'm going to show you that 900 user papers per year, 6,000 user per year, and 1,800 project per year. It's because we support all the academia research in Taiwan. And here are the utilization of our computing facility. So for the CPU base, it's basically still numerical simulation type of thing. If you take a look at the number one environment and disaster mitigation, the 28%, sorry about the character. And if you take a look into the detail of that, about half of it is on the numerical simulation for climate and weather simulation, all right? Especially when there is a typhoon, and the Central Bureau of Weather, they have their own machine, but they also use our machine because they have lots of assembly model to run, and especially in time in the matter. And the chemistry is still the biggest user in the CPU machine. But you come back to the GPU, and the 37% means ICT. I think most of them are AI related. Also, biomedical with AI, and also AI technology, all these things. So it's add up like more than 60% of GPU are used by the AI related research. But here we observe one situation, that is the rising of Kubernetes, right? So we are kind of deal with this kind of situation later on. So people ask what happened to us after AI has come to our world. So I cannot tell you how much job is increasing for each of us, but I can tell you what's the budget, because you see how every employee of the center is bearing on how much money on their shoulder, and you might guess what's the loading of their job. Okay, so the blue line is the number of employees we have. We kind of a little bit increase on the number at the end of last year, not many. But if you see the budget, the red line is called huge, shooting up like that. So it take an average, you will see the green line. Green line means each of us is carrying how much budget to spend. Of course, it's not in my pocket. I prefer to have that. But if I have that, I won't be here today. So and you can see we have lots of different hardware. So we kind of build our iService. So user can come up here and choose the machine they want to run, or even the service, right? So this something we are working on, and also in production use of this. And here are the future plan of our system, right? So we are basically our funding for infrastructure is funded by these two projects. One is Taiwan Chip-Based Industry Innovation Program, and also Southern Taiwan Silicon Valley Project. There's two huge projects, and the goal is to provide like 480 petaflops at the end of 2029. And here we are in the stage of 2026. This year, the target is 196. I don't think we can reach it because the budget issue. And it's not a budget issue because the price of computing is getting higher and higher. But in 2027, we are looking at the possibility of 13.6 megawatts of power consumption, according to the plan. And the end of 29, we're going to face the 23 megawatts. So that's why we built the first new data center last year, which provide more computing power. Let's see, I can skip this one. Here, okay, the newly innovated computing data center is like they provide 15 megawatts computing capability, and also the building is like a green energy building. It's like 1.7 and 1.3 in PUE. The floor of loading capacity is 1.5 tons, but in the new machine room, supposed to be here, to be in place in 2029, we kind of designed this place to have 90 megawatts of computing power, but the loading of the dock is almost twice. because GPU is getting heavier, bigger and bigger, too heavy. And our existing machine won't be able to hold it, all right? So I'm coming back to, instead of only we build a machine ourselves, we also try to coordinate private sector of Taiwan. There's lots of different companies, they are building their own computing power and try to sell to the industry. So we kind of try to make alliance. So if our job is too many for us to consume, we overflow to theirs and vice versa, okay? And this is ongoing, and it's kind of hard to deal with private company. They won't tell you how much I have, right? They just want you, give me your job, right? So in addition to increase the capacity, we also try to squeeze every juice out of our computers. So we kind of adopt the machine learning to predict the loading of the system. The reason for doing this is because the system is running on queuing system. So you have several queues, and this queues was designed by our system, I mean, based on their experience. So we kind of provide, okay, this is how we predict the loading will look like, and try to adjust your configuration. So after this, our prediction is like a 1% in error, so it's quite accurate. Then we do the PSO optimization, and to suggest how do you tune this configuration. This is the result of this on the left side. And also the increase of performance is like 21%. So if you do it properly, you can squeeze more computing power out of it. And this is the machine room I just mentioned. In addition to supercomputing, we're also running the R&D research network of Taiwan. So far this year we have 4 lines of 400 gigabits of network in the backbone. So end up like 1.6 terabits on the backbone. And also we upgrade the connection to the US. To Chicago, still stay with 10, but to the LA is like a 100 gig. And here I would like to draw your attention to the ION. We are working with ION. The reason for doing this, because we are looking into the quantum communication as well. Okay, so that will serve as a base platform for the development. And this is AI initial program of Taiwan. Just skip this, I have to show that. And this is how we deal with AI. First, we need to provide computing power, also high efficient data center, and we develop our own Taiwan AI Lab. Basically, it's an AI model, but we kind of move along and go above beyond that. Here are the basic service provided by AI Lab of Taiwan. It's like 3 tiers of service. You can actually come to our center, use our facility, train your own model, or you can use our API to construct your model, construct your service, or you can simply use our inference service provided. All right, this is, we have dedicated team to work on this, and these are the service they provide to the community. We have called OmniGPT, similar ChatGPT, of course, not as powerful as it is, but we blew ourselves. And also we have a chatbot for our iService team, and we have something like a software development team, and also the API service, blah, blah, blah. So it's kind of typical AI service mechanism we're going to provide. And on top of this, we're kind of moving into the direction of AI for science. Now, this is something we did like 5 or 6 years ago. When AI first came to our center, we kind of integrate the 4 medical center of Taipei, and they are working on the acoustic tumor in the brain. So each one of them have their own image. And then we provide a federated platform for them to share the model instead of data, okay? And we kind of first experience with this. And also we work with the CNN to generate a surrogate model for engineering application. But nowadays, as AI move on to the agentic, and also the MCP and inference type of things, we actually did a test run with this AI-assisted scientific equation, because we start with, what we did is we tell the LLM, say, give me a 2-dimensional numerical simulation of computing fluid dynamics on the airfoil. So it went on the website, pull out a very basic not a double 12 airfoil, because lots of people using this for evaluating their result. So he knows that, okay, pull out the best one. Then you go on the website, go on the internet to find a mesh generator to generate a mesh. Then find the proper solver and do the whole thing. So it took me about 1 day to build up this whole workflow and submit to run. But in this case, 20 minutes is done, right? And this is the result. So I'm going to yeah, it's up there. So I'm just going to fly through.
Sorry about that.
Yeah, no problem. And this is quantum computing we are going to do, but it's still under procurement, and we got a lot of things to learn. And it's nothing different from other computing centers, what they are going to do with it. This is how we go, we are working on this. Okay, so this is the summary of what we have done so far: infrastructure, platform, numerical simulation in AI for science, then the LLM model, and the future with quantum computing, also the new data center. So that's about it. Thank you.
Thank you, Weicheng.